Hello everyone, I'm Komal and I solve Leetcode daily challenge questions and upload the videos on my channel. You can check out my channel for other topics like bit manipulation, prefix sum. I have created a playlist for that also, and also recently I have added streams. Okay, Java 8 features streams. Okay, and you can check out that. And let's solve today's this question. So the question is target sum. So you are given an integer array nums and an integer target. You want to build an expression out of nums by adding one of the symbols plus and minus before each integer in nums, and then concatenate all the numbers. For example, if our nums is 2 and 1, let's say, you can add plus before 2 and minus before 1 and concatenate them to build the expression plus 2 minus 1, and return the number of different expressions that you can build which evaluates to target. Okay, so for example, we are given this one. Okay, so we are given this 1 1 1. For each one we have what? We have two options. That is, either we can use this as plus 1, or we can use this as a minus 1. Again, for the second one, this second one, let's say instead of 1 I'll take 2. I'll take here, I'll take 3. Okay, so for 2, okay, for 2 we also have again two options, two choices, that is plus 2 or minus 2. Again we have one, for that also we have plus 1 minus 1. Then we have again 3, that is plus 3 and minus 3. We have 1 plus 1 minus 1. So we can have, for 1 we can have two choices. Okay, either plus or minus, and we can use any of this, and we can create an expression. Okay, we can build an expression that is plus 1 minus 2 minus 1 plus 3 plus 1, or we can say plus 1 minus 2 minus 1 minus 3 minus 1. Okay, so we can have, let's say for example, we'll take some expressions, that is 1 plus 2 plus 1 plus 3 plus 1. Okay, which results some, okay, output. Then again 1 minus 2 minus 1 plus 3 plus 1. Again we can have 1 minus 2 plus 1 minus 3 minus 3 plus 1. We can have this as well. We can have minus 1 minus 2 minus 1 minus 3 minus 1, right? So we can have multiple expressions. What we have to do is we have to return number of different expression that you can build which evaluates to target. So we will be given one target, so here it is 3. So if we find the sum of this, if we evaluate this expression, that is 3 plus 1 4 5 6 and 8. This is 8. Then this is 1 and minus 1 get cancelled. Minus 2 3 minus 2 is, okay, this minus 3, this plus 3, and then we'll get 2. Then here we'll get 1 plus 1 plus 1 3, 3 minus 3 0 and minus 2. And here we'll get minus 1 minus 2 minus 3. Okay, 5 6 7 8, so it will get minus 8. So we have different sum. Okay, so we can have multiple expressions, because see, you can see this 5 with this one, or we can, like, you can say, we have so many expressions, different expression, we can build a tree out of that, that we choose instead of plus 1 we have minus 1, and then we combine this minus 1 with all other this. Okay, so we can have multiple like that. We have to calculate all the sum, and we have to check with this target if it is same. Let's say we have one more here instead of hmm, let's say here we will use this example. Here the example is different and target is 3. So let's say our target is 2. Okay, and then we got this expression which results in 2. So we can get other this other expressions also, right? For that we might get some as a 2. So we have to calculate or count basically that how many expression we can build to get our sum as a 2 after evaluating that expression. Okay, so this is what the question is. Let's see how we can solve it. As I said, what will be the brute force? We can consider this plus 1, and then combine with all, like plus 2 we can combine with minus 2, then plus 1 minus 1 plus 3, this. Then we can consider minus 1, then combine with others. Then we can consider plus 2. Likewise, we can have multiple expression using for loops and all. Okay, so the next approach is, okay, so if you know the concept of recursion, when we can apply or when you can use the recursion, when we have choices. Okay, basically, if you have choices, they can then you can use the recursion. This you keep in mind, because this will be helpful when you will be solving the questions based on DP. Okay, so that time whenever you have recursion approach with two or more choices, then there is a possibility of using DP. Okay, so like this you have to think. So when you can use the recursion when you have a choices, because you have choice, that means you can call, right? So recursion is basically you are calling the same function, so you have two choices, either plus one or minus one. So I can say for plus one do this thing, and for minus one again do this same thing with using the minus one. Okay, so we will use one method which will do our task, and we will call that method based on our preference, that which we want to select. Okay, so let's solve this. In the recursion we have base condition, we have recursive calls. Okay, so let's say I'm writing one method public which will not return anything. It will just check, or we can say calculate count. Okay, it will say calculate. Okay, now what all things we have to pass, we have to pass nums our array. Okay, because every time we want what array that number, right? First we want one, then two, one, three, and one. So we will get that number from this array only. And next thing is index. So using what we will choose this array number, which element we will choose using the index. That okay, initially it was 0, now 1, now 2, now 3. So keep track, basically to keep track we'll need an index. Then we need a target, because using this only we will be checking, right, our sum is equal to target or not. And the last is sum, that we will be calculating and passing. Okay, so what will be our base condition when we have to stop this? When our index is equal to what? Nums dot length. Nums dot length. Okay, then what we have to do? Then we will check what if sum equal to target, and if both are equal then we will increment our count. And for that we have to take one count. Okay, I will use this count here, and I will initialize in our this method count equal to 0. Okay, and we will increment our count. Now what two choices we have? One is add, one is subtract. Okay, so for add what we can do, we will call the same. We will pass the nums array, we will pass the index plus 1, that is next index, and then we will pass the target. Then for sum what we will be doing, sum plus initial sum value. As we are adding, so we will add nums of index. Okay, and for subtraction what we will be doing, using this same method, with here I will just subtract. Okay, so now this is our method for recursion. Okay, now this is our method for recursion. We will call in our array, sorry, in our method. Okay, here I'll calculate nums. Initial index will be 0. What is a target sum? What is target, and sum will also be 0, and we will return our count. If I run this, yeah, okay, so here we are getting an array out of bound index. Okay, so here we have to return, right? Base condition is for what? We have to stop it. So I just, as we are not returning anything, I'll just add a return statement. Yeah, you can say accepted. Let's submit this code. So using recursion you can solve this is the first step. Okay, so you can see, but it is not giving a good I mean, of course recursion is like you will calculate the same, like we have a tree and we are doing the same thing again and again, right? Because we are checking every possible solution. That is fine, we can solve this using recursion. That is what I wanted to tell you. And next thing is, okay, now what we did, we tried solving using recursion. So but here we like we want to optimize this. So what is the next thing? What I told in the beginning of this video is, in the beginning means before solving this, before writing the code, is when we have choices then it is a recursion question. Okay, and when we have two or more choices, that means there is a possibility of using DP. So instead of using DP, in this video I'm going to tell you about memoization. Okay, so that means in the recursion, if you know, okay, we will build a tree, or let's say I'll here, okay, I'm sharing this only, so I might not be able to show you other screen. So okay, I will show you, just a minute. Yeah, um, okay, okay, so by mistakenly I started recording different screen and I was just talking and I lost this time. Okay, so I explained these things. Let me just undo and I will explain again. And sorry for this inconvenience that I'm doing this in front in this video only because I already lost so much time. um okay, so last time what we did is using recursion. Okay, so using recursion, we solve this question. So I was telling that how we can optimize the solution is using memoization technique. So whenever you get a question like this where you have choices, okay, you have more than you have more than two choices, and that time you are using the recursion. Okay, so as I said, I already explained. I created a video, but I shared a wrong screen and so I lost that time. Okay, so here you can see, let me undo again this also little bit so you get. Yeah, so here you can see, let's say this is our example and our index 0 and sum 0 our starting, and we have two branches, right? One is add, one is subtraction. So one we will add or subtract. So if we go to the add path, our index 1 for the next number and the sum will be 1 because we are adding, and if we go and subtract, our index is 1 but sum is minus 1 because we are subtracting, and the current sum is 1. Again, if we add 1, this one, then our sum is 2 and subtract 1. Again, for this minus 1, if we add 1, the sum is 0, and if we add uh, again minus, if we subtract 1, then we'll get minus 2. Okay, and again, if you see for this node, we index 3, sum is 2 plus 1 is 3, 2 minus 1 is 1. Here 1 plus 1 is 2, 1 minus 1 is 0. Here 0 plus 1 is 1, 0 minus 1 is minus 1, 2 plus 1 is 3, 2 minus 1 is 1. So here you can see sum is 3, sum is 3. Or you can see minus 1, 1 and 1. Okay, so let me check if my screen, yeah, I'm recording correct screen. Yeah, so here my 1 1 1. Okay, so our sum here you can see index 3 and sum 1. That means from this branch, okay, from this node, how many expression I can build if I store in this. Okay, I let's say I know how many expression I can build from this, that is sum 1 and index 3. If I know that, then I don't need to calculate again for this, right? Because the answer will be the same. Again for this also the answer will be the same, right? So we don't need to calculate this again and again. So instead of that, we can store it somewhere and we can check it that if our solution, if for this index and for this sum, if we have a solution or not. That means from that index, from that node, if there are expressions and these are already calculated or not. If not, we'll calculate. If yes, why we need to calculate again, right? We can just return the same. So from here I can return the same thing here, and it will be going. That means we don't need to calculate again and again, right? So this is the thing I wanted to tell, that memoization in recursion, we are calculating repeating things, like we have repeated calls which will give the same result. For, I'm not saying it's the same result exactly, but if for sum 3 and index 3, if you have multiple nodes for with the same value, it will anyway return the same result, right? Because it will have the same branches again, same path, so no need to do that again. So it will return, we can use this memoization technique to store it and return. So let's start coding. So we will use what, we will use one 2D array. Okay, so here t is equal to new int nums dot length plus 1, and okay, here what is our sum ranges between minus 8 to 8. Okay, but here if I say my sum is minus 8, can I store this, use, can I use this for an index? No, right? Because it is a negative. So instead of that, can I use from minus 8 to 8, can I use 0 to 16 instead of that? I can use, right? Because I can consider this minus 8 as a 0, minus 7 as 1. Because let's say if I add plus 8 here and plus 8 here, so it will go from 0 to 16. So I'll use this index. For minus 8 I will use 0, for 8 I'll use a 16 index. Okay, you got right my point. Because here, then here what size we need, here we need a sum, total sum of our array into 2 plus 1, because 16 is will be our index, so our size should be 17. So here 2 into our total sum, total sum plus 1. So what, how we can calculate the total sum? So let's say total sum is equal to arrays dot stream. Okay, of what? Stream of nums dot sum. It will return us total sum. So okay, if we want to know about streams, I use the list, and explain the streams how we can use. I created a playlist. I will add that link in my description, or you can check out in my channel. Okay, to get to know about the streams more. So I got a total sum 2 into total sum plus 1. Now I don't need a count, and I don't need this count as well. I'll return this because we will change this calculate method. Okay, now in this calculate method we want to return int. Okay, so what I want to do is, if my target and sum are both equal, then I will return 1. That means this expression, it will return 1 count, else it will return 0, because we want to add, right? If it is there, then it will return 1. That means one more count. Instead of incrementing the count, we are just returning 1, so that we'll get to know if we are able to build the expression with this path or not. Now here, as I said, this is a int, so int add is equal to an int subtract. That means from this path, from this index plus 1 and sum plus this path, how many how many I will get after adding? Okay, this is after adding only, right? So after adding, here you can see after this path. Okay, so how many I'll get for this amplitude, and for this I'll check for the negative. Okay, so like this, int add and subtract. Before that, what is the point of memoization? Is we will check. Okay, just I missed one thing here. What we have to do, we have to just put something in this array, right? 2D array before, so that we can check if we have updated that array or not for that sum and index. So I will just fill it with minimum value. So int arr nums, not nums, t, and here arrays dot fill arr comma what, integer dot min value. Okay, so I'll fill this, and here I can check with that, right? So I can check with, t of index and sum plus what, total sum. Because as I explained earlier, why we need a total sum, you can just rewind and check why I'm using it. Integer dot min value. If it is not equal to this, that means here we have stored already the solution for from this index. So I will just return the same thing. Okay, else we have calculated again. We can store this in add plus sum, add plus subtract, sorry, and we will return this, not this. Okay, that means here you can see for add, from add I have this branches, I got some count. From this I have got some count. I have to include both for this solution, right? So that is what I'm doing here and returning it. So let's run this. Okay, cannot find the symbol. Yeah, definitely, because we haven't here included total sum. Okay, now run. We have initialized here and declared globally, okay, in this class. So let's submit this. So we have seen the recursion approach, you have seen the memoization approach. Here you can say accepted. Okay, so anyway, it is good, optimal than the recursion, because in recursion we were using the repeated, I mean we were calling the repeated calls. Okay, so now we are avoiding that, storing it someplace and again using that. Okay, so I just wanted to tell you one point here using this question is, let's say in any online assessment or coding test, which will be the first round of the placement, or you can say any process. Okay, so there if you get such question and you don't know, you know that this question can be solved using dp, but you don't know how to solve, then you can use this memoization approach or recursion, whatever you know. You don't need to know dp only, because sometimes the solution may get accepted, right? Here you can say accepted because this is a lead code question, not a online assessment, right? There is a possibility that it will give a time limit exceed or such any okay, warnings, or you can say they want a dp solution only, but not necessary, right? You know the dp solution. So instead of that, you can try with the recursion, you can try with the memoization before going to the dp, if you are not confident about the dp. Okay, so this is what I wanted to tell. So you can use this approach, or you can use this technique. Think, we have choices. Here you had choices, right? Plus or minus, you can add. So we have choices. we can use with the recursion. If we are able to apply the recursion, then we have two or more choices. That means we can use the memoization. If you are able to do the memoization, that means BP is easy. Okay, so think like this. Okay. Yeah, so in this video I just wanted to tell about recursion and memoization. I mean, solve this question using these two approach. And if you want if you want DP solution explanation, then please comment on this video. I will create one more video for DP solution. Okay, thank you so much for watching this video. If you feel this video is helpful to you, please like this video and subscribe my channel. Stay updated.